Hello all. Today we are solving LeetCode problem number 1161, maximum level sum of a binary tree. So you are given a binary tree basically, and your ask is to find the sum of elements at a level and find which level holds the maximum sum and return it. And if you read the problem carefully, return the smallest level x such that the sum of the all values of node at level x is maximal. So what exactly this mean? So if you encounter in any level, if the maximum element is present in two levels, let's say the maximum sum is present in two levels, return the lowest level. So that is what they have asked in this particular sentence. So let us understand this with the first example. So in the first example we have the root node as 1, and we have a child node for root as 7 and 0 and 7 and -8. So this is level 1, and there is only one node and the sum is equal to 1 at level 1. And level 2, the sum is equal to 7 plus 0 is 7 and level 2. At level 3, there is sum is equal to 7 plus -8, which is -1, and level 3. So among all these level, the maximum sum is 7. So you have to return level 2. And if in case if there exists level 4 and you have only 7 here and the sum is 7, in this case you have two levels where the sum is 7 and the sum is the maximum sum. So in this case you have to return the minimum level, so minimum among two levels, right? So that will be 2, so you have to return 2. So how will we solve this? So basically this we are processing by levels, right? So when we think of levels, we have to we what strike in our mind, so we directly jump into BFS, right? So and this problem is all about finding the maximum element, right? So I mean maximum sum. So for maximum sum we need to traverse every nodes of the tree, right? So because of that we have to anyway traverse it. So how we are solving the problem, we have to traverse and then calculate. So how are we solving it? By traversing all nodes and calculating sum and comparing the max and finding the max. So for traversing we are using BFS because we have to process everything by level order. So and to find the sum, calculate the sum and track the maximum, we have to use variables. So we will be starting from the first node. So and in the first node you have to store this node. So we use in BFS we use queue. So we have a queue, um, so we have a queue and we have the nodes present here, and then we store usually at we process by level. So at each when we are processing the first level, we will have all the nodes present within the queue, and in second level we have all the nodes present within the queue. So that is how we traverse in BFS. So I will come to that a little later. But for tracking the maximum, what all do we need? So if we are in first level, we need to track the level, and the level will be 1 because that is what we are starting from, and we need to calculate the sum, uh, maximum sum. So we have to initialize that to be negative infinity, because we need a very small number to compare with the sum to find the maximum. So that should be initialized as negative infinity. So and also we need to track the maximum level, because we are not returning the maximum sum, right? So we have to return the maximum level. So we are tracking the maximum level using maximum sum. So max sum level, so that also will be initialized to 1, because definitely we are having root node. And one thing, we have to track the sum, right? So at each level, so we are using level sum to track. So this will be initially initialized to 0, and we have to but at the end of processing a particular level, we have to uh, we will have the sum stored in this level sum, and then this gets reassigned back to 0 to process for next level. So this will not be global, this will be inside the loop, and these things we have to keep it global to track for the complete tree. So at level at fruit node, we have level as level 1, and these things will be the same for level 1, and level 2 we have 7 and 0, and the sum becomes 7. So and this level gets updated to 2 in this the next when we are jumping to the next level. And what happens here is maximum sum is 7, and then this gets updated to 7, and maximum sum level, this is level 2, and hence this gets updated to 2. And even in the level sum, this is what this is the one value which gets updated first, and at the end of iteration this becomes 0, and we have 7 and -8. So we are jumping to next level, so this gets updated to 3, and the sum is -1. So we compare with the maximum sum, here the sum becomes -1, and we check if this is a maximum sum, which is if it is greater than maximum sum, not. So this still remains the same, and since this remains the same, this maximum sum level also remains the same. So we came to the end of the loop, and what happens is the queue becomes empty. There is no elements at queue, and we return. So this is how the solution is, right? So now with all this in mind, let us jump into coding part. So we are doing level order processing, which is BFS, right? So and we need a queue. So queue is, we are initializing using dequeue. So and we have to start with the root node, and as I said, we need few variables to track. So one is level is assigned to 1, and max level, this is also assigned to 1, because we are starting from the root node. and this is assigned to negative infinity because we need to have a lower value to compare with other sum to find the maximum sum. So we for BFS we will iterate, we will loop it until the queue becomes empty. So first we have something in element in the queue and we process it based on that. So this runs until the queue becomes empty. So while queue, and we have to have the level sum to track the sum at each level. So and now we have to iterate, because we have to iterate through the queue and fetch or remove or pop the all elements. So we have to pop it from the left because we traverse go by left to right. So because of that we have to pop the elements from the left, because the left node will be always present in the left side left of the queue. So because of that we have to iterate and pop it. So for I in range len of q, and you have node is equal to q. Oh, okay, so now when you pop left you fetch the node. So now you have to sum it with the, for finding the sum you have to get the value and add it to the level sum variable. So and now before getting out of the loop you have to append the left and right node of that particular node if it is present to into the queue, so that it will process in the next iteration. So if node dot left, if it is there, then similarly if node dot right. So now we are done in this loop. So we will be now we have to compare the sum with the maximum sum, I mean the level sum with the maximum sum. So if here we have to update two things actually. So we have to update the maximum sum to level sum, and we have to update the level the max element max sum level also. I guess the naming is correct, max sum level. Right, now we have to update the level by 1 before entering into the next iteration. So when the queue is empty we return the value and we return and when it is coming to time complexity it will be order of big O of n, because we are traversing each and every node for processing the sum, right? So for space complexity this will be different because it will be the maximum width actually. So by this maximum width what exactly it means is whichever level has the maximum number of nodes, that is the space complexity for this particular problem. So let me go ahead and submit it. And there you go, this is an efficient solution. Thank you.